Hi everyone. I guess we'll get started here. Welcome to another Common Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. Today we're going to begin somewhat of an initial discussion. Particularly, we're going to be looking at another, I wouldn't say containers library because it's much more than containers library, but it does have a bunch of built-in containers. The past few weeks, as many of you know, we have been looking at various containers libraries. FSET, Sycamore, CL containers was last week. This week we're going to begin looking at and exploring the Lisp Interface Library. Library that does have a bunch of built-in containers, extensions essentially on top of the existing common Lisp containers, but it's much more than that. It's a design philosophy that was created by Francois Rudeau back in 2010, and he presented this at ILC, the International Lisp Conference, in 2012. The talk is available. He actually did a updated talk to the Boston Lisp meetup, and that was recorded and is available online. I think if it's either that one or the ILC one. I will post the talk in the YouTube description once we're done with today's session. But I thought I'd at least begin the discussion with a little bit of some of my experiences as I've been looking at this library, because the library itself presents a design philosophy that is very similar to folks who may have come from other programming languages that may had parametric polymorphism. So some examples of this would be OCaml, C++, Java with generic, Scala, and so forth. These languages have a way of allowing you to define essentially skeletons of a particular algorithm or set of algorithms that abstracts away the data type data structures upon which those algorithms were written on. So as long as you know that this particular object adheres to, for lack of a better term, this interface that implements these methods, you can then leverage this algorithm. Now, the author of this library actually uses interfaces as the base unit for exposing this. What he did was he created essentially a style of programming where the dispatch mechanism that's used in CLOSS is a first-class interface object. That's what he likes to call it. And that first-class object defines the methods upon which the object instance that you're operating on should actually have in order for the algorithm to work. Otherwise, you'll get some errors. Now, my initial experiences of this, and I have been working on this for this past week, have been somewhat confusing just because I'm trying to wrap my head around his particular examples, mainly in that there is a particular approach that you have to take in order for you to define your own custom interfaces and then leverage his existing interfaces and his existing data structures. But by doing so, what he has done is he created a way for you to essentially have a different dispatch mechanism than normal multiple dispatch. It's actually a complement. It's built on top of multiple dispatch and multi-methods inside Common Lisp. And it allows you to define, instead of object containers with specializations using def method, you could use this interface object to actually define objects that are more pure or stateful depending upon your use case. We will address some of this in various subsequent parts of this conversation, but primarily I'm going to be showing you a couple of examples from his GitHub repository and just working through them just so that you could get somewhat familiar with the approach, and then next time we'll start actually discussing some of the particulars of the library, mainly because some of the examples that I thought I got up working to get a better understanding of it just didn't work as well as I thought they would. So rather than having this being a live coding and debugging session for a few hours, I thought it would be best to at least go with what's already available in the examples in the library through essentially like a code walkthrough. And then this way we could get a better understanding of what is going on. So let me pull up the actual library. And there's a particular example that the GitHub documentation, if folks have are looking this up themselves, there's two particular examples that can show its usage. So if you just give me a moment, I will just pull up the library itself. Perfect. Okay, so what was this? Okay. Back to here. And Lisp software. And in here, it's in the test directory. Okay. Okay. So before we get started on this particular test, what I'm going to do is I'm going to fire up my Scratch buffer just to give you a top-level overview of the design metric. So to begin with, the Lisp Interface Library is available on QuickLisp. To load it, it's just, just like any other. It's not actually, you don't have to type in Lisp Interface Library. You can just simply type in LIL. In this case here, I've already compiled this library, so it'll just quickly go through and load it into your REPL. But when you, for new folks, just a reminder, any new library you load from QuickLisp that hasn't previously been loaded into your system, what happens is behind the scenes is QuickLisp will download it from the internet, from I think it's AWS. There's a QuickLisp server running on there. That's where the distribution packages are, and it will compile it for your particular Lisp image prior to loading it into your system. Now, QuickLisp, the Lisp Interface Library is actually a set of different packages. Okay, it isn't just any particular old package. The best way to actually see this is running apropos on LIL to see what packages were actually loaded with the LIL moniker on. And if we run this, you'll see that there is a huge slew of packages that are available in this. Now, and the reason I'm starting with the packages and the list of packages that are available is it kind of illustrates the basic design philosophy of LIL at a very, very top level. The goals of the library were dynamic languages like Common Lisp, particularly in the case of Common Lisp, have normally for a long time only had or some form of ad hoc polymorphism, which for many of you who aren't familiar with the term is just, one example of it is like function overloading. So the idea is you have different the same function name but different function signatures with different arguments. You pass, when you're invoking a function, arguments, and based on the argument, it will determine what function to actually call. So an example of this, and I'm just going to write this in C to make it simpler, is let's say that you have two square functions. One actually returns a square, an integer based on what was actually passed. Okay, so we have this return x times x, and you have another one, let's say double, and square now takes in a double. Now in C++, what would you would do is you would actually go in and normally it will compile these as two separate functions with two separate signatures, and when you invoke square with an integer argument, it will go and look up, see if there is a function that has been defined for integers named square, and then go dispatch on that. Similarly with square, if you pass in a double. If you pass in a float, there's other intricacies in C++ or C that have issues with implicit conversions and things like this. But the bottom line is the type system and the types that are specifying the arguments determine which function is actually going to be dispatched on. In Common Lisp, we all have something similar to as well. Now, not necessarily at the function level, but certainly if you use, say, type-based dispatching using class, because as many of you know, the Common Lisp object system, especially when you're using the multi-method dispatch, actually determines the specializations based on the type of arguments that are being passed into the function. And that actually determines which method in the method table is the one that you would ultimately dispatch on. And given the fact, and when I say multi-method dispatch, folks, is there might be subclasses. There's two dimensions ultimately for the functions that are being called when you're using Common Lisp object system, as most of you who have been following us along may have figured out. Because of this, Common Lisp object system and Common Lisp in general provide ad hoc polymorphisms, much like many of the other languages. Now, when we start talking about the notion of doing what's called parametric polymorphism, we're talking more like languages like C++, in particular their feature of using templates to write out their algorithms. In the example, again, to follow this example in C++, you might have something like a template of a type named t, and then you might have a t square t return t. All right. Now, obviously, for folks who are thinking about modern C++ program, I'm not using modern features here. I'm just illustrating the idea of what templates provide in C++ and to illustrate what parametric polymorphism is actually doing. In this case, what you're doing is you defined essentially, as the name says, a template of a particular algorithm. Obviously, this is a very simple algorithm that assumes that the type that's being passed into the algorithm has the multiplication operator, which is somewhat of a type constraint. It will allow you to make sure that types that do not necessarily have this operator or this function present will end up throwing up a compiler error in the case of C++. Other languages like Java, Java generics, I could show you a Java generics example too that it has essentially a similar fashion. But the point is this template is written once, right? The notion of actually defining this generic algorithm is very powerful. Actually, it allows you to essentially abstract away the type requirements or the characteristics of a particular data structure that you're using away from the actual algorithm itself, and allows you to write more generic algorithms for different data structures. Now, in the context of the Lisp Interface Library, unfortunately, Common Lisp does not, and for folks who are more experienced Common Lispers, if I'm completely off my rocker based on my understanding of this, let me know, and I will retract anything that's incorrect. But my understanding of Common Lisp is that it does, while it supports ad hoc polymorphism, it does not necessarily support something like this that's parametric, primarily because since Common Lisp does not is dynamically typed, right? You can write generic algorithms, algorithms that are generic enough such that if you can write an override for them, you can certainly do so, and the interpreter at runtime will determine whether or not it can dispatch on that, and if it can't, it'll go ahead and throw up an error. Now, we're not talking about compile time stuff, just because, as most of you know, although Common Lisp compiles to machine code, the one thing it does not do is do a lot of massive type checks. In fact, some of the most basic stuff, and you could see this again if you just simply do a disassembly on any simple function. It has generic operations that it could use and operate on actual arguments that are being passed into the function. So if it's able to determine it, some Common Lisp implementations will use types and infer the types and actually make sure that it can get optimized the code. But unless you have actually annotated the defund with some type declaration, it will not be able to determine some of that stuff. Does the idea make sense for folks so far? Any questions about this? Let me just check the live stream. Okay. So in the Lisp Interface Library, its goal was to essentially take it upon itself to extend the Common Lisp object system and almost complement it in a way, because it is built on top of the Common Lisp object system, of abstracting this idea of being able to write parametrically polymorphic functions that is similar to those that are done in languages like C++, Java, Haskell, OCaml, and so forth, but not change just syntax in such a drastic way that it will be almost as if you were writing a completely different language, right? It tried to stay as Lispy as possible, and the way it did it is through this idea of creating first-class interface objects. Okay, and this is an example of. I'm just going to pull up an example of such an interface. Give me a second here. /interface/alias. Just do this here. Describe. Describe. this is just showing me the class precedence list. Let me go into the actual code. References. Yeah, that's the one. Okay. Okay, I'll bring this back later. This way we can get some real estate. Okay. So this is an example of a interface inside the Lisp Interface Library, right? Now, there's a couple things here that obviously is a little jarring. One, for example, we didn't actually define the interface in this particular case here. The actual definition of a list is, if I remember correctly, it's in, let me just pull that up. It's in Roswell, local projects, not local projects. This software, Lisp Interface Library, pure Lisp. Okay. So this is an example of an interface in the Lisp Interface Library. Now, a couple of things about this that I'm going to first bring up and just talk through. This is the reason I'm going through A-list, which is their essentially the most generic version of maps and hash tables and stuff. It's dealing with all key value kind of data structures. So you have either, in the case of associative arrays, a list of key value pairs, or in a certain hash table, you might have a dictionary that's hashed on a particular key, or something like that. All right, its main goal is to actually figure out and handle the most generic algorithms for dealing with associative key value pairs. All right. It's fairly complicated here, so we'll go through it one at a time. But the idea of it is fairly simple. The interface library, the interface itself determines the set of operations that it can actually operate on. And notice that the interface itself does not actually define the methods upon which the interface is actually working on, all right? And this is, in the case of a lot of the built-in interfaces, this is by design, primarily because I think even though there is a way of writing an interface that that looks like, you know, a common Lisp def class, which we'll talk about in a little bit. Even though it can be written that way, from a lot of the examples I've seen, especially for larger uh, pieces of code. Um, Instead of actually writing out the documentation and defining the generic functions for each of the operations, instead the author went instead to using implementing the A-list in terms of defining its methods in a separate implementation file, mainly so that the implementation and declaration may have to be close together. I wasn't. That's at least my thought on some of the A-list specific functions. Now, I haven't actually gone through all of these interfaces, which we'll talk about in a bit in a second here. But as you can see, each of these are there's a lot of them. All right, so there might be methods that kind of cross over and stuff. But I'm jumping ahead of myself. Let me just talk through this this code piece a little bit. So A-list and interfaces in general follow a particular pattern inside the Lisp Interface Library. Right? All interface objects defined by the Lisp Interface Library, and as I understood it, the best way to actually implement it is also follow the same pattern in your own code if you define and use this library for first-class interfaces, is that you define the interface object itself with angle brackets. This is the easiest way to know whether or not you are dealing with an interface object or with an object instance that is associated with Common Lisp Object System. Define interface itself is written in such a way that ultimately it is a macro that will essentially expand into all this code. But I'll touch base with that in just a second. Define interface allows you to declare what the name of the interface is and a bunch of interface superclasses, each of which might have one or more functions associated with it. In addition to that, to get the kind of parametric polymorphism that is normally attributed to other languages, like the ones I mentioned before, you have a set of slots after the Lisp, the interface class precedence list for the superclasses that it's going to inherit from, and this is what's actually used by the dispatch mechanism that Lisp Interface Library uses to parametrically call a dispatch on a particular implementation of this interface. Now, there are additional things that you can add here on top of that, and those are essentially the constraints upon which you want your parameters kind of to adhere to. So like in the case of this example here, if I just clear this up a little bit, you can see that the only specific things that it is requiring for all objects that are implementing this interface is that the key interface must be EQL, which is a different interface. It makes sure that you can deal with equality at the EQL level. And the value interface can be any type. All right, that's what the any interface is. Okay, and what it does is it actually then uses that to this parametric thing is essentially an interface constructor that would ultimately create an instance of this interface with the key interface and the value interface. And once it does that, then it will be used to go and do the dispatching. Now again, I might be digging into this in a little bit more deeper detail than most application developers are going to be using it, but understanding this concept will let you go really far with this library. Specifically, the reasons is with this library, based on this particular style, as you can probably tell with some of the names of the packages that are available, you could then start adopting some interesting patterns, like in the case of coming from languages like Haskell, you could probably build functors, applicatives, and monads directly. And in fact, the author did so with some of his examples. Now, this library isn't complete necessarily, and he admits that there's some future work that he wants to do, but it is fairly complete for day-to-day work. It's complete enough. All right, no library is complete, but it's complete enough. Its design has been tested, and if you go and look at some of the GitHub issues, the author himself said that it can be used in production code. So we've defined this interface. How do we actually go and use it? Now, this interface didn't actually define any methods on it, as you can see, other than us actually defining what the interface inherited from, what are its type constraints on the key interface and the value interface. There isn't much oh, and also this is a singleton interface, which my understanding, pretty sure I'm going to butcher this, but my current understanding of it is that there can be only one type of this interface, and it makes sure that it cannot be inherited twice, and there can be no more than one instance of it. But it's basically a singleton object because it's a class singleton, but I'm not entirely sure what actual implications of this specific declaration does for its use across being implemented by multiple objects and multiple algorithms for that matter. Now, but as you can see here again, there's no implementation of any of the algorithms that are associated with ALIS. We just know that it has some sort of key interface, some sort of value interface, and it works off of those. All right. So where do we actually go and define these functions? Well, like I mentioned before, in this particular example, and again, if you read, and this is in commonlisp.net, there is the ILC 2012 actual presentation in its entirety available, which is what I've been following to actually go through this library, and I'll also link that in the list. But if you read that, he specifically said that A-list itself, again, is the more complete example for this case study, which is again why I'm just mentioning it again for folks just joining us. And it's again separated between interface declaration and interface implementation. So let's go and look at the interface implementation now. I'm going to close this up just so that we can actually get some more screen real estate to actually go and look at some of the code. The implementation file defines all the methods upon which work on the objects that adhere to this interface. Okay. Now, this is also a set of macros that were defined in order for you to define methods for registration and things like this. If you actually look at what this macro does, is there we go. A second here. Is it defines essentially a macrolet on defining methods that are associated with this particular interface. Now, this key argument here specifically is something that you should look at. It essentially transforms into the defined interface method, the single defined interface method. So let's go back to what what this was originally. This is allowing you to wrap a set of methods, define interface methods, and this method with the arrow here is defining an interface, a single interface method. And what it does is here's what it was originally. You're defining the method name, you're specifying a map and a key, and what it transforms into is essentially a specializer. Okay, it automatically injects the actual interface into here, and specifically it transforms that define interface method is another method that transforms into a def method that's essentially specializing on that interface as the first argument, then the map and the key. Generics do the same thing here. They actually make sure that when you're generically defining something, you're actually defining it still with the specializer on the interface. When you define that, it ends up also injecting this particular thing, which is the with interface macro. The with interface macro is essentially a macro that generates essentially like an applet form that defines a bunch of functions, essentially locally defined functions that will match to all the methods that are inside a list. Okay, let's see how this looks like. If we expand this, you can see all of these guys are basically just applying the appropriate method that is already available for this interface to the specific argument that was passed in. Okay, and a lot of these methods that you saw, because we didn't see any method declarations, come from the inheritance hierarchy that was actually associated with this A-list interface. Okay. I thought that was pretty cool because that means then what this macro does is it essentially provides you a locally scoped instance of the API, so that you can actually then use it to your advantage and implement the algorithms without having to worry whether or not a particular method is available or not to you. The one thing that this example does show, though, is interfaces can inherit from other interfaces, like I said, but more importantly, if you're defining generic algorithms, if you could split up the interfaces into very small ones and then compose them using the inheritance hierarchy, you can end up coming up with far more flexible designs. Specifically, you can actually define specializations on interfaces in such a way that your data structures specialties, let's say in the case of like different tree implementations, the only thing that you would need to implement for any given algorithm is the differences between the data structures, not what they're in common. So in the case of depth first search, right, whether or not you're using graphs or trees or what have you, you are basically looking for a leaf node. All right, you are looking for a node. In the case of a graph, using graph terminology, you're looking for a node with no outgoing edges. And if you're thinking about a tree, is essentially a node with no children. But they're fundamentally the same thing. So you could, in such a way, define different interfaces so that depth first search can be implemented for all data structures that have these characteristics. And then if you need to use that for a weighted graph, you can implement the cost function in a completely separate method and have the dispatch system handle all the combinations for you for free, which is really awesome. A couple things that I wanted to bring up that were interesting about this. Obviously, the methods themselves are pretty straightforward. Once you know what a specific data structure provides, you can see here that you can actually leverage the key interface and the value interface for associative lists, which are your parameters in your parametric constructor, by just simply calling their appropriate generated accessors on the object, and then it will appropriately dispatch on that object. Check to see if the key interface or value interface method exists. If it does, it'll go and return the appropriate, key or value, and you can then implement some very generic functions for this. So, like for example, for lookup here, what we're using is because this is an associative list, ASOC is what you would probably normally use, which takes in the association, the item, and the list, and then returns whether or not it'll return the value and whether or not the actual value is found. I'll defer you to actually go into the ASOC documentation, which is a standard common list function that we've used in the past, for more information. But one thing I wanted to show you was at the bottom of here. I'm ignoring a couple of concepts here just because I think we're starting from kind of like the base level for this discussion. I don't want to overwhelm you with also dealing with some of the advanced type-based functional programming concepts like monoids, functors, monads, and applicatives. But for the sake of actually dealing with A-lists and transforming between things, this is something that that most people need to be aware of. Although you have this generic algorithm, because we're building it on top of this ad hoc polymorphic dispatch system, there were a couple of workarounds that had to be made, specifically so that we could mimic what would ultimately be done by any statically typed language at compile time, and that is dealing with type conversions. In this case, if you're passing in between different types of interfaces, you would have to essentially write overrides to convert and have some convenience methods so that users of your library can actually transform conveniently from their interface to your interface. So in this example here, the author defined essentially a converter that would convert from a map into an associative list by using his generic fold right mechanism to actually reduce the map object into an associative list. Similarly, you can see here he's using this map A list to convert from a map to an A list. I don't know why he did destination, source, and then map, but it seems to be a common thing in a lot of his methods when you actually look at it. And obviously, in this case, in here, he had he created an A list to map converter that also called the map the convert function from map to A list, and we will see a similar implementation of this inside Lisp Interface Library. I'm sorry, inside the map class of the Lisp Interface Library. One thing to be aware of, before I conclude in this particular part, is that the actual interfaces themselves are separated from different implementations, which obviously constitutes ways for you to actually use different types of things. The one thing that I wanted to bring up here is, and this is what I've been actually dealing with, is the is how to essentially, I can show you an example of how to actually use this library in some basic situations in the case of using A-lists and maps. But there is one thing that I'm not entirely sure that I'm dealing with, and I'm just going to present that here so that if folks know or have ideas, we can work through it. But I'll just go ahead and move first. So to use this, once you've defined your library, okay, like this, obviously you want to be able to use it in particular cases. So an example that was available inside the presentation I thought was pretty neat was the fact that you can actually go do something like this. You can actually go and look up and say, actually, let me do this. See if I can actually do look up. Where's the way right here? Oh, got it. So, the way to actually use this library to make it so that it's generic enough is you have to actually go and specify using the use package what it is that you're going to be leveraging. So, let's say for example I use pure map low, pure map implementation, pure A-list, and let's see if I can do this. Pure A-list implementation. Oh, right, sorry. You can only do that as if I defined a package. Let's do it this way. I'll do it that way. Make it easier for us. Let's go back to our scratch buffer. Okay. So let's define a package, and let's call it AFP LIL examples, right? And let's say that we're using CL, LIL, pure map, LIL, pure map implementation, pure A-list, and pure A-list implementation. Okay. So what we're doing is we're essentially specifying here those packages whose symbols that we want defined inside of our package. So we're going to go ahead and define this. Go ahead and use this package afp.examples. Let's do this. So now we're in our examples, and we want to actually go and look up, which takes in a map, A-list, and we want to go ahead and just simply, for the time being, go ahead and determine that we are working on presentation. We're looking up the value of a particular key that's inside of the associative list. Okay, this is the canonical example of actually using a using this library specifically, and using more, in this case, what I'm writing, which is an associative list. And let's see, let's try and change so the topic is on Lisp. Right? So now we want to actually pass in. So for folks who just to review what an associative list is, associative list is a set of key value pairs, where the key in this particular case is not essentially a symbol. It's essentially a symbol that you would have to quote, otherwise you're going to get an error. What this is going to do is it's going to look up, using an associative list, this guy. And we can go ahead and grab this, print it out. You can see that it becomes 2021. Now, but let's say that we want essentially a map to actually go through this instead. So we have our map to A list, sorry, an A list to map. Okay, we have to specify the map that we want. Okay, and we're going to go ahead and change this simply to now map data structure. This works. You can see this is what I've been hitting yesterday. This is an example of the use case that's directly from the current API, and I'm pretty sure it's because I'm misusing this particular example. But I was sure that, because A list is defined, map is defined, there's a transformer map that maybe I have to go and specify. But for some reason, just using it in this way is causing some issues. It's saying that it's an unbound interface, although we clearly can see it defined inside LIL pure map. It might be because of the inside the package that is actually dispatching it on the map function. The map is not defined, but that's really weird because, as you saw, A list inherits from it, or inherits from some stuff that's defined in the same package. So I wouldn't be surprised. It should not be. It just looks a little weird. So I was going to go through this example here and just show you essentially the idea of what's going on here, and then next time we'll go through how this is actually worked through once I get the kinks out on how why this particular case is not working through it. So, are there questions about kind of the basic design philosophy and some of the instances of some of the code that we went through? I know it's somewhat short. It's just because I've been hitting somewhat of a roadblock when I'm working through this library. But I thought I'd at least give you an idea on what I have, because understanding it, the epiphany of this library and the value of this library cannot be understated. Just because, at least for me, writing generic algorithms and writing generic data structures minimizes a lot of issues that I currently have with many current languages that are, with the exception of maybe C++, just because although it's somewhat of a different language in itself when you write it in that style, it at least provides this functionality. But being able to do that gives you the ability to actually switch between pure functional persistent data structures versus knowing when to use state. And for anyone who's written large-scale software applications knows, being able to document it, in the very least, the places where state is being manipulated makes code so much more maintainable, because then you're avoiding certain edge cases, because the majority of your system is written in such a way that the actual code itself is just doing, for the most part, a functional mapping from one object to another object, and I think that's pretty neat. So that's what I have today. My apologies for not being able to get much more, just because this is the roadblock that I got stuck on, and I spent the last couple of days trying to figure out what it is I'm doing wrong, and I still haven't actually found any specific resource on it. Which brings me to uh, somewhat of a request. This library is a very nice library in terms of what it provides, and I know it requires a bit more code spelunking to understand what it needs. The one thing that it is lacking in terms of its usability, like real usability across large swaths of folks in the community, is clear documentation on how to use the library, how to define interfaces, and so forth. The only thing that I was able to find on this library, which is still fairly detailed, but it's more of a design documentation and a justification in terms of its philosophy of design, than an actual thorough tutorial. Is it doesn't have the kind of documentation that that would help more folks to actually use it and appreciate it. I'm trying to at least spearhead an effort in trying to see how to actually document this, which is why I'm spelunking the library. For folks that are interested in such an effort, please ping me on I'm on functionalprogramming.slack, has Bugram. I'm also on the Lisp Discord server, has the same name. Go ahead and ping me with ideas and questions, and I could certainly work even examples on that to be like, hey, this would be a clear case study on how to leverage this, and I can use that as a basis to write some more documentation to get some feedback. But that's it for me. Are there questions? Are there any questions in general? I mean, I'm willing to take any questions regarding Common Lisp or anything that we've talked about in the past too. How is package inferred system? I don't. So one question came up. How is package inferred system? I don't believe I am familiar with package inferred system. Is that a Oh, you're talking about as this package inferred system. Okay. Yes. Okay, so I have not actually looked into the advantages of using package inferred system. It was written on my notes. It does seem to. I don't believe that is an issue with it being listed in central ASD file. Okay, so the question was regarding, is the package inferred system potentially being the reason why the map not being found? And the package, as you clearly saw, the symbols are loaded into the image, and it successfully did load into the image. And from that point on, my understanding is ASD is out of the picture. So ASDF ASDIF is completely out of the picture after image loading. So Once you have your compiled facils loaded into your image, all those symbols should be available at this. I think in this particular example, that error that you saw is related to an object instance not being constructed correctly. So that is interesting because there are a bunch of transformers and stuff that will construct objects, and it might be the case that, and this is my suspicions honestly, that I'm not explicitly providing a concrete implementation of that interface, and as a result, there is no way for it to actually go in and construct a map instance. That's just my thought. I can't say that for sure, but I have a my hypothesis seems to be pretty grounded given the fact that, as you saw earlier in that example, let me just undo a couple of things to show you what it was originally. This guy clearly is recognized by the Lisp interface system as being an instance of an associative list. So my guess is since that we're asking that map to a list to construct a new instance essentially of a map structure that adheres to the same interface, and it can't find a concrete implementation of it, it's not binding that to the map interface, and as a result, the lookup is failing. That's just my current suspicion on that. Okay, so the question about how would I go about debugging this? So one thing to note is there's a couple of examples that are in section 4 of, and I'm gonna again post this, but if you look at the 2012 implementation, the 2012 presentation paper that's available online on commonlisp.net. And it goes through various sections on this. I think what I need to ultimately look at, and this is probably why I haven't been able to successfully do this, is I have to understand Section 4 and interface transformations in order to go about debugging this and figuring out the causes of it. But one way of doing it is obviously stepping through the code. You can actually put a manual breakpoint inside when the function gets invoked. And then use the built-in debugger to step through and see where the construction is actually failing at. Another way is also potentially using a trace to see, go through the stack trace to see where exactly the error is being thrown and work from there. Okay, so other questions. I'm just getting started with Common Lisp. Just wanted to get a sense of it. Okay, so Ian, we have a new Lisper. Welcome, welcome to the Common Lisp Study Group. I appreciate you joining us. New Lispers are welcome year-round. If there's anything that you need help with in terms of setup and development stuff, feel free to ping me. I'm a squatter on usually all those Slack channels that I told you. We have I think a good starting point to get yourself up and running quickly is actually watching our video on setting up your environment using Spacemacs, mainly because a lot of Common Lispers that are just starting tend to get tripped up on the development environment. There's already a built-in like dev environment kind of like thing that's using Slime. I'm forgetting the name of it right now. I think it's Lispbox. I don't know if it's still maintained or not, but it runs, it gives you everything in like one executable. But if you are already an Emacs user, yes. The comment on Shinmera's protocol is, I was thinking of Portical actually. Shinmera's Portical is another one too. That's actually awesome. Okay, so if you're a longtime Emacs user, getting up and running with Slime is, or even Sylvester, which is kind of a successor to Slime, both are valid. You'll get up and running very, very quickly. I think, in fact, Sylvester or Slime is, if you're a longtime Emacs user, is available on Melpa. Practical Common Lisp, yes, that's a great starting point. We have videos on that. Additionally, if you, on top of the actual book itself, the physical book, it's also available in its entirety online um, through Apress. Thanks to Apress being very generous to allow us to have that awesome book. Before I let all of you go, a couple of things. I just found out, I should have, that the second edition of Programming Algorithms in Common Lisp is available now through Apress. It was originally done through LeanPub. I missed the deadline to actually grab a copy of it through LeanPub, so it's not available anymore. But you can get, Apress is a great place to get Common Lisp books, and they have this, which is a very nice book on actually implementing algorithms in Common Lisp. Any other questions? Great. Oh, okay. So, for folks who aren't familiar, there was a book out there that was written by a series of blog posts on actually writing algorithms in Common Lisp itself. It was originally published, Programming Algorithms in Lisp, Writing Efficient Programs with Examples in ANSI Common Lisp is actually the full title. It originally was published by a different publisher. Its second edition is now available on WordPress. It was just recently. It was recently released at the end of January, early February, and I just found out about it a month and a half ago. So I'm grabbing myself a copy. Apress, apress.com. Hey, not WordPress. This is a very complete book that goes through data structures, goes through algorithmic complexity, big O notation for folks who've forgotten it. Then it goes through a lot of your standard data structures, hash tables, trees, strings, graphs. I think I saw in at least the table of contents in the first edition. It goes through some standard algorithms that most people are familiar with, like Boyer-Moore. There's a full section dedicated, and if anything, this is one of the reasons why I'm purchasing the book. It's dedicated to implementing dynamic programming algorithms correctly in Common Lisp. As well as sections on compression and synchronization, which are topics that nowadays are becoming more and more important. So I encourage you all to grab the book. I'm planning on doing somewhat of a thorough review of it. Maybe even try and see if we can do like a reading group of it with some examples and stuff that we come up with. But I'm mentioning it now before I forget. Okay, question on web development platforms for Common Lisp. Okay, excellent. Good question. Now, the web dev space for Common Lisp it depends on what it is you're trying to accomplish. I'm gonna put it that way, rather than saying that it has everything. If you're doing web prototyping, then there's a bunch of stuff that's available for you. There is a lot of Eitaro Fukamachi's work. So things like check out Caveman or Ningle, or these are web development frameworks created by Fukamachi that are fairly complete web frameworks for prototyping, but they are like the best analogy that I could say is Ningle is kind of like Sinatra, and Clack is more like sorry, not Clack. Caveman is more like Ruby on Rails in terms of its design. And the link that was provided by there's also in the Lisp cookbook a specific section dedicated to actually doing web development on it. Some of the work in there I will mention is going to talk to you about using Hunch and Toot. Hunch and Toot is like the web server for Common Lisp. But what Fukamachi has done recently, if you want to make it more production worthy and set it up so that you can actually leverage like a production web server that's available on say like AWS, Clack is a library that you should check out because it allows you to hook into industry standard grade web servers. It implements the actual web server gateway interface that's similar to what Python provides. It's actually, yeah. And the other thing that I'm going to mention is, and this is something that and folks in the community that have ideas on this, feel free to ping me with those. I'm more than open to actually checking some stuff out. But one thing that is, I would say, missing in the story, if you will, is if we want to keep it somewhat turtles all the way down, well, enough before we have to hit external tools, is being able to dispatch and create containers directly in Common Lisp. That is something that does not currently exist as far as I know. I know there are tools that will hook into Docker. If you look at Cody Reichardt's awesome Common Lisp library, which is a list of curated libraries for Common Lisp, he mentions a set of Docker images that might be useful for creating production quality Common Lisp applications on the web. That might be a good starter, so I'll provide that link too as well. I am planning on doing a more thorough overview of the web dev space in Common Lisp. It's just been it's a moving target, honestly. And I'm trying to figure out what would be the best net to cast over to give people an indication on what's available and what's not available. That way, it doesn't actually become an outdated video that needs to be revisited every now and then. Although it's probably useful to do that anyway. Okay, question on Arc. Honestly, I have not heard news on Arc for a long time. I actually at one point thought it was dead, but I could be wrong. Paul Graham, forgive me if it don't hate tweet me. I'm not saying Arc is not a bad language. I'm just saying that I haven't heard much movement in that space. So, but if Arc is still alive, I think it's a good design. I mean, it's the one thing I will say. Arc itself as a Lisp is very minimalist. It follows the same principles that the original Lisp had, but I would make the same argument with Scheme. Scheme up until R5RS was an extremely small language. I think the actual language itself in standard library was about 50 pages. I think R6RS and R7RS has increased the number of features that were in the language, but some of it was out of necessity. I'll be honest with you. There was a discussion that I had a few weeks back regarding the importance of the condition system and having a condition system actually. And as it turned out, one of the reasons why R7RS became somewhat bloated is because R6RS became somewhat bloated, but they trimmed it down a little bit in R7, is the fact that condition systems were a missed opportunity in the scheme side of things, and they tried to adopt one, but they couldn't adopt one that was standard enough, primarily because by that point a lot of folks wrote their own condition systems or stuff that looked like one, and as a result they had to come up with a lowest common denominator that would work across those, so they couldn't break any code. So, when you have that much variety, you're going to end up having to do something that will accommodate everybody. It's rather unfortunate, but I understand why. It's you don't want to break code that's already working, and that's actually one of the appeals for Lisp. And honestly, for folks listening in on it, one of the testaments to Common Lisp is that its standard is standard. It's a basis. It's not a moving standard. Common Lisp is alive and well, but the standard is a basis for everything else. We let the innovation happen at the library level, and there are a lot of libraries that are out there for development in this language. Other questions? Okay, well, if there aren't anything, I will see you guys next week. We're going to continue our explorations. I hope I've given some pointers for the new Lispers. Thanks for joining. And just a reminder, folks interested in helping out with code spelunking or documentation of Lisp Interface Library, please ping me so we could see what we can do to rectify this situation and actually come up with something that others can use. Thanks, I appreciate it, and I'll see you guys next week.